Hi students. Progress. In this lecture, I am going to discuss potential due to spherical shell and potential due to solid sphere, and after that self energy. Let us see first one, potential due to spherical shell. Right. So earlier we have learned while discussing shell theorems due to uniformly, sorry, when we are taking a spherical shell of uniform mass distribution of mass uniform. Let us take mass is capital M. Let us use a capital R, distribution of mass uniform. In that we have learned gravitational field is 0 inside for R less than R, and that is equal to just like a point mass. Okay, it is just like point mass when you take outside, that is R greater than capital R. This is what we have learned in shell theorems, right? Now we have to find potential. So here what we are saying is when you are taking outside, it is same as due to point mass. Now taking same logic here also, potential. Potential will be minus Gm by R, same as due to point mass. So R is greater than or equal to capital R, means outside or on surface. Okay, right. Now observe carefully the definition of potential. It is work done by external force to move unit mass from infinity up to that point slowly. Means if you are taking up to surface, then we have to consider in the place of a small r, it is a capital R. Means potential on surface, it is minus Gm by capital R. But from surface to any point inside, to move it, no work is done. The reason is that there is no gravitational force inside. That means, I will write here, work done to move from infinity up to surface. That is also equal to work done to move from infinity to any point inside. Any point inside. Reason is up to surface, there is a gravitational force. So we have to do some work to move it slowly. But to move it inside, no work is required. Therefore, both are equal. That's why at any point inside, potential will be same as that on surface. Okay. So see the point carefully. From infinity up to surface, how much work is done? Same work is done from infinity up to any point inside. Because from surface to inside, no work is done. That's why it is minus Gm by R. Okay. This is due to spherical shell, right? Now next one is due to solid sphere. See how to calculate for this. So now we are going to use the result in case of solid sphere. We got field equal to G m by r cube into r. This is for r less than or equal to capital R, right? So while discussing shell theorems, we got result Gm by r cube into r. This is inside the solid sphere. And when you are taking outside, it is same as due to point mass, means Gm by r square, right? So now we want to calculate gravitational potential inside, because coming to outside, we value directly minus gm by r, same as due to point mass. Okay, so we want to calculate inside. Then see here what we are doing. So we have discussed that g is equal to negative of potential gradient, right? So I'm writing here gm by r cube into r, that is equal to dv by dr. See how we have taken this. When you are taking the spherical, or it is solid sphere, field is always radially inwards. Field is radially inwards. So when r is increasing, that means when we are moving outside, potential will increase. That means dv by dr will be positive. Okay. So if it is clear, remain just calculation part. See carefully. dv equal to gm by r cube into r into dr. Now integrate. And we want to calculate at one point inside. Therefore, what I am doing here, take one point on surface, means capital R. This is V on surface. And take at one point inside, that is small r, corresponding potential is V, which we have to calculate. Now, V minus Vs is equal to, take gm by r cube outside, remaining is r square by 2, right? Check it once, it is r square by 2. I am taking 2 outside. It is r square minus r square. Okay. And here we have to substitute Vs equal to potential on surface equal to minus gm by capital R. Now substitute this in this one. Suppose this is 1 and this is 2. So take now 2 in 1. Okay. Then we are going to get V value minus gm by 2r cube into 3r square minus r square. Okay. So this is for r less than r equal to capital R, means inside. Right. And we got here potential outside, same as due to point mass. Right. That is potential due to solid sphere inside and outside. Let us see next one, self energy. So what is the meaning of self energy and how to calculate that? Let us see the first one. We are calculating for first for spherical shell, distribution of mass uniform. So first one is for spherical shell. So first understand what is the meaning of a self energy. Take one spherical shell. Okay. Mass is m, radius is r. So here what we are doing is we are bringing small masses from infinity to construct one spherical shell. I am repeating. We are bringing small masses, we can say dm, from infinity to construct one spherical shell. Okay. So in the process of constructing spherical shell, work will be done. and that work stores in the form of potential energy. Okay, that means we are bringing small mass, keeping on surface of the, you can imagine one shell here on surface. Next, bring one more dm. But in this process, what happens is the mass which is on the shell attracting this dm. So we want to move it now very slowly. That means to overcome this attraction, we have to exert some force. So by that force, work is done, and that work stores in the form of potential energy. Let us take at one point of time, its mass is small m, and we are bringing now dm from infinity, bringing dm mass from infinity. Now, work done will be equal to integral. So here what we can write, just recollect once, W equal to, by external force work equal to, it is delta U, right? Work equal to, which is nothing but M into delta V. Okay. This is what we got while defining potential difference. Potential difference equal to delta U by M, or work done by external force by mass, right? Now use that result here. Potential difference bringing from infinity, that means their potential zero, coming to on surface, potential is minus gm by r potential. So potential difference equal to, this is the potential difference into mass dm. Like this, we have to bring total mass, how much, from 0 to capital. Okay, then see how much we get. G and R constants, m dm, m square by 2. So it becomes now minus gm square by 2m, sorry, 2r. This is now stored in the form of potential energy. So this is the self energy of a uniform spherical shell. Okay. Let us now calculate same thing for solid sphere. So take one solid sphere. We want to construct a solid sphere of mass m, radius is r. Okay. Let us consider at one point of time. At one point of time, we have a solid sphere of mass. We can say solid sphere of radius is smaller. Okay. So initially there was no solid sphere. We are bringing small masses dm to construct one solid sphere. Okay. In that process, at one point of time, we are having a solid sphere of radius is smaller. Okay. Now we have to construct solid sphere of radius capital R and mass equal to capital R. Now we are bringing masses to increase radius from R to R plus dr, to increase radius from R to R plus dr, from R to R plus dr. Then see how much mass is required. How much mass? That mass will be rho into 4 pi r square into dr. This is a mass required to increase that radius from r to r plus dr. Okay. So work done is equal to integral. Again, same relation. Same relation. In the place of dm, I am writing rho into, or in the place of rho, what I can write? Rho equal to 4 by 3, sorry, rho equal to mass by volume, right? Rho equal to mass by volume. Rho equal to mass by volume. 4 by 3 pi r cube. Okay. So I am writing here in the place of dm rho into rho value 3m by 4 pi r cube, that is rho, into 4 pi r square dr. This is a dm into change in potential. Okay. That is now minus g by small r. In the place of a small m, I can write capital M by r cube into small r cube. See carefully once, this is nothing but m by 4 by 3 pi r cube into 4 by 3 pi r cube. Okay. So here 4 by 3 pi r cube is cancelled. I have taken directly here. Now like this, we have to increase radius from 0 to up to capital R. See calculation part. So coming to a calculation part, 4 pi gets cancelled. Next, what else here? 1 R is here and 1 R gets cancelled. Remaining, I can say 3m minus, take constants outside, minus 3 gm, 3 gm constants, r cube, r power 6, r power 6. Remaining is now r into r power 3, r power 4, r power 4 dr. It becomes r power 5 by 5. Okay. So this is equal to minus 3 by 5 gm by, sorry, it is m and m, right? M square gm square by r. This is now self energy of solid sphere. Okay. That is about self energy. If they ask any problem like basing on this, see how to solve. Suppose we are given one spherical shell. This is a shell. Mass we can say m1, radius is r1. This is now solid sphere. Mass is m2, radius is r. And between their centers, separation equal to small r. Now calculate potential energy of the system. Then potential energy will be equal to self energy plus interaction potential energy. Self energy plus interaction potential energy. Coming to self energy for spherical shell, minus g m1 square by 2r1 for solid sphere, 3 by 5 g m2 square by r2. Because of interaction, when you take because of interaction, we have to take these two as 2-point masses at their centers. That means it is now minus g m1 m2 by r. This is now potential energy of the system, sum of the self energies and interaction potential energy. Okay.